Welcome to this session. This session, we are going to do an example on numerical integration by using Simpson's 383. So the first part of the question is to find the exact value of the integral, this integral here. And then second part is to approximate now the integral in A above by Simpson's 3A through, not third. So solution. First part, we use calculus. Integral minus 1 to 1 dx 1 plus x squared. By definition, this is tan inverse of x, negative 1 to 1, which will be tan inverse of 1 minus tan inverse of negative 1. And when you work out properly, you get pi over 2. So part B, from an 1, we want to use 6 intervals of the Simpson's 3A rule. So remember, we need to get h, which is given by b minus a over n, to be 1 minus 1 over n, which is 6 for this case, 2 over 6, which is 1 over 3. Now, in that integral, f of x is 1 over 1 plus x squared. So that we need to make a table of values, x and f, minus 1, then plus 1 over 3, you get to minus 2 over 3, plus 1 over 3, you get minus a third, plus 1 over 3, you get 0, plus 1 over 3, you get 1 over 3, and then 2 over 3, and then finally 1. Putting these values of x in the function, we get when x is negative 1, f is a half. This will be 9 over 13. This will be 9 over 10. This will be 1. This will be 9 over 10. 9 over 13, a half. Now, once you have this table, you label these values of f as this half is fi, f naught, this is f naught, f1, f2, f3, f4, f5, f6. And so by Simpson 3A rule, we have 3h over h. Endpoints, we have f naught and f6. And then plus 3 times all the multiples of 3 ordinates. We have f1 plus f2 plus f4 plus f5. And then plus those twice those which are multiples of 2. So we have only f3. We don't write f6 because f6 is an endpoint. It's an end ordinate. So h is 1 over 3. So when multiplied by 3 over 8, we get 1 over 8. So a half plus a half plus 3 into 9 over 13, 9 over 10, plus 9 over 10, plus 9 over 13, plus twice f3 is 1. Now, when you work out this, 1 over 8 into 1 plus 621 over 65 plus 2, which is 1 over 8 times 816 times over 65, which is 102 over 65. Please confirm this and this. So we have 1.569, 230,769. And error in this calculation will be given by exact value minus approximate 1.569, 230,769, and this will give us 1.565557564 times 10 raised to minus 3. Percentage error be given by the error over the true value times 100%, which will give me 0.00996649001%. If you compare this answer to what we did for the case of trapezoidal rule, the percentage error when n was 6, in the case of trapezoidal rule, the answer was 0.58%. So you see, comparing this one to the trapezoidal rule, whose percentage error when n is 6 was 0.58%, this one is 0.09%. So it's better than trapezoidal rule. And for the case of Simpson's third rule, when n was 6, the percentage error was 0.00915%. So the other one was 0.00917%. So this is smaller than this one, which shows that Simpson's third rule is still more accurate than Simpson's 3/8 rule, but Simpson's 3/8 rule is accurate as compared to trapezoidal rule. And then lastly, when n is 12, so we'll have h1 minus 1 over 12, 2 over 12, which is 1 over 6. So make a table of values, x and f, -1, minus 1 over 6, 0, 1 over 6, 1 over 3, and then a half, 2 over 3, 5 over 6, and then 1. So this is a half, that's 6 over 61, 9 over 13, 4 over 5, 9 over 10, that's 6 over 37, 1, 6 over 37, 9 over 10, 4 over 5, 9 over 13, 6 over 61, half. So immediately you make this table, you label your F values. So this is F0, F1, F2, F3, F4, F5, F6, F7, F8, F9, F10, F11, F12. So integral will be 3h over 8 into end ordinates F0 and F12, and then plus 3, all those ordinates that are not divisible by 3, plus twice all those ordinates that are divisible by 3. So F3, F6, F9. You don't add F12 because it's already an end ordinate. So that's where I stop. And if you input in all these values, this integral I should get, I will simplify to 1/16 into 1 plus 18.9326676 plus 26/5. So 26/5 is the value at this point. This one is for this middle term, and this is for this end ordinates, which on simplification is 1.570791,725. And you can find the error by saying error is a half pi minus 1.570791,725. This will give you 4.6017949 times 10 raised to the power minus 6. And if you calculate percentage error using the usual procedure, error over true value times 100%, you get 2.929593622 times 10 raised to the power minus 4%. Now, when you compare this answer when n is 12 and when n was 12 for the case of Simpson's third rule, the percentage error in that case was 2.77 times 10 raised to the power minus 5, which is less than this value for Simpson 3/8 rule, which is 2.93 times 10 raised to the power minus 4. So in summary, one, with same number of intervals or strips, Simpson's third rule is more accurate compared to Simpson's 3/8 rule and trapezoidal rule. And then number 2, the higher the number of subintervals, the better the approximation. Is the same as the more accurate the approximation. And in this case, you see, comparing the same number of intervals in the case of Simpson's 3/8 rule and trapezoidal rule, answers here are also more accurate than what we got for the same number of strips in trapezoidal rule. So that's a summary on how to deal with those 3 kinds of numerical integration methods. Do more examples and things will make sense to you. Thank you.